Hi guys, welcome to another episode of Learn with Sir Glenn, and for this video, we're going to discuss factorial notation. So, let's go! So before I proceed with the factorial notation, let's review first your fundamental counting principle. So how many ways can you arrange 6 persons in a row? So if you arrange 6 persons in a row, there will be 6 selections. So selection for the first position, second, third, fourth, fifth, and sixth position. Then for the first position, we can choose out of 6 persons. So there will be 6 choices. For the second position, we're going to have 5, 4, 3, 2, 1. Then if you want to get the answer to how many ways can you arrange 6 persons in a row using the fundamental counting principle, we multiply the choices for your selections. Therefore, we will have 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. So notice that whenever you arrange persons, objects, letters, numbers, where the repetition is not allowed, you will always end up with a number multiplied to a number minus 1, then multiply again to a number less than 1 to the previous number until you reach 1. So this kind of number is commonly used when it comes to fundamental counting principle or counting the possible outcomes. So therefore, there's another way of writing this set of numbers, and that will be our lesson for today, which is factorial notation. So there are several definitions of factorial notations, and here are some of the definitions. The process of multiplying consecutive decreasing whole number is called a factorial. The notation for a factorial is an exclamation point. So in mathematics, when you use the exclamation point, it is a factorial symbol. So the factorial of a non-negative integer n, denoted by n factorial, is equal to n times n minus 1 times quantity n minus 2 times quantity n minus 3, and so on until 3 times 2 times 1. So the factorial notation, which with symbol exclamation mark or exclamation point, says that you have to multiply all whole numbers from our chosen number down to 1. It's a short way of writing of multiplying consecutive decreasing whole numbers up to 1. So it's just like the example a while ago where you have 6 times 5 times 4 times 3 times 2 times 1. You can actually express that in factorial notation. Okay, so for example, let's say you have 6 factorial. So the 6 factorial is actually the factorial notation of 6 times 5 times 4 times 3 times 2 times 1. So which is 720. So the use of factorial notation is to make it easier to write those kind of number, especially when you're going to use those numbers in solving or in solution. So instead of writing 6 times 5 times 4 times 3 times 2 times 1, you can simply write 6 factorial. If you're going to arrange 6 persons in a row, you can just simply use 6 factorial, which is always 720. So another example, so let's have 4 factorial. So 4 factorial is 4 times 3 times 2 times 1, which is equal to 24. Then 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to 5040. Then let's have the 9 factorial. So 9 factorial is equivalent to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to 362,880. So in factorial notation, you can also encounter the recurrence relation. So in the factorial is defined by the recurrence relation n factorial is equal to n times n minus 1 factorial, where n is greater than 0. So to make it easier to understand, let's have an example. So let's say we have 4 factorial. So if you expand 4 factorial, you will have 4 times 3 times 2 times 1. But if you're going to look at the part where you have 3 times 2 times 1, this is actually the same as 3 factorial. So since 3 factorial is always 3 times 2 times 1 when you expand, you can replace 3 times 2 times 1 with 3 factorial. So therefore, instead of writing 4 times 3 times 2 times 1, you can just simply express 4 factorial as 4 times 3 factorial. So this is very useful if you're going to use the factorial in solving. So let's have another example. So let's say you have 7 factorial. 7 factorial is equivalent to 7 times 6 factorial. So another example, 6 factorial is equivalent to or is equal to 6 factorial times 5 factorial using the recurrence relation. And aside from this, you can also expand your factorial up to specific number factorial. So for example, we have 9 factorial. You can expand this as 9 times 8 times 7 times 6 factorial, and you will have the same value. In factorial notation, 0 factorial is equal to 1. So you may ask why. We can use the recurrence relation to show that the 0 factorial is equal to 1. According to the recurrence relation, n factorial is equal to n times n minus 1 factorial. So let's say that n is equal to 1. If n is equal to 1, we're going to have 1 factorial is equal to 1 times 1 minus 1 factorial. So 1 factorial is 1. So 1 is equal to 1 times 1 minus 1 is 0 factorial. So simplifying this, you will have 0 factorial is equal to 1. That's why the 0 factorial is always equal to 1. So I told you a while ago that factorial is used when solving. So therefore, we can apply operations on factorials. And when you apply operations on factorials, so since the factorial is just a multiplication, we have to use the PEMDAS in performing operation on factorials. So the PEMDAS stands for parentheses or the grouping symbol, exponent, multiplication and division, addition, and subtraction. So therefore, we're going to perform first those operations inside the parentheses. Then after that, you evaluate the exponents. Then you perform multiplication and division, whichever comes first from left to right. Then addition and subtraction, whichever comes first from left to right. So when you apply operation on your factorial notation, you have to apply or you have to follow the PEMDAS rule. So let's say you have 4 factorial plus 3 factorial. The common mistake made by student is you just simply add 4 factorial and 3 factorial, which will give you 7 factorial, which is wrong. So what we're going to do is to get the value of 4 factorial and 3 factorial first, then you add the 2. So therefore, we will have 4 times 3 times 2 times 1, which is 4 factorial, plus 3 times 2 times 1, which is 3 factorial. So if you already know the values of 4 factorial and 3 factorial, you may skip this step. So that will give you 24, which is 4 factorial, plus 6, which is 3 factorial. And this one will give you 30. Okay, so let's have another example. So let's say we have 6 factorial minus 4 factorial. So again, do not subtract 6 minus 4. That's wrong. What we're going to do is to get the value of 6 factorial and the value of 4 factorial. And that will give us 6 times 5 times 4 times 3 times 2 times 1 minus 4 times 3 times 2 times 1. So if you already have the value of 6 factorial, which is 720, and the value of 4 factorial, which is 24, you can skip this step and you will have 720 minus 24. And that will give us 696. So let's have another example. So 3 factorial, 4 factorial. If you see factorials written side by side, the operation involved is actually multiplication. Or sometimes you will see them in parentheses, or you will have dot in between the expressions. So for this one, we can simply have 3 times 2 times 1, which is 3 factorial, times 4 times 3 times 2 times 1, which is the 4 factorial. Or you can just simply have 6 times 24, and that will give you 144. Okay, so let's have another example. So let's say you have 6 factorial over 3 factorial. So you are dividing your factorials. So you can have the value of 6 factorial, which is 720, divided by the value of 3 factorial, which is 6, and that will give you 120. Or you can expand 6 factorial as 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, which is the expanded form of 3 factorial. And notice that since we have 3 times 2 times 1 on our numerator and we have 3 times 2 times 1 on our denominator, you can cancel those numbers, leaving you with 6 times 5 times 4, And that will give you the same answer, which is 120. Another method is using the recurrence relation. So since we have 6 factorial over 3 factorial, what we're going to do is to expand 6 factorial up to 3 factorial so that we can cancel the 3 factorial on the numerator and denominator. And that will give us this one. So 6 times 5 times 4 times 3 factorial over 3 factorial. So we use recurrence relation to your 6 factorial where we expand it up to 3 factorial so that we will have 3 factorial on the numerator and 3 factorial on the denominator, and you can cancel now those 3 factorial on numerator and denominator, and that will give us 6 times 5 times 4, which will give us 120. So you may use any of this method to solve for dividing your factorials. So let's have another one. So let's say you have 9 factorial over 7 factorial. So using recurrence relation, we will have 9 times 8 times 7 factorial over 7 factorial. So now we can cancel 7 factorial, leaving us with 9 times 8, which is 72. So another one, 8 factorial over 5 factorial. So recurrence relation, we will have 8 times 7 times 6 times 5 factorial over 5 factorial. So we can cancel 5 factorial, leaving us with 8 times 7 times 6, which is equal to 336. Let's have another example. So 7 factorial over 5 factorial, 2 factorial. So notice that this time we have 2 factorials on our denominator. So if you solve for this one, what we're going to do is you simply choose one of the factorials on your denominator that you want to cancel. And normally, we choose the bigger factorial so that we will have smaller numbers on our solution. So we're going to expand 7 factorial up to 5 factorial, and that will give us 7 times 6 times 5 factorial over 5 factorial. Since we have 2 factorial, we expand the remaining factorial. So what we're going to do next is to cancel 5 factorial on the numerator and 5 factorial on the denominator. Then, if you notice, we can still cancel some of our numbers such as 6 and 2. So you divide 6 divided by 2, then that will leave us 3. Or the remaining numbers will be 7 and 3. So we will have 7 times 3, which will give us 21. So 7 factorial over 5 factorial, 2 factorial is equal to 21. Okay, so let's have another one. So let's say we have 10 factorial over quantity 10 minus 3 factorial. So according to the PEMDAS rule, we're going to perform first those operations in parentheses or in the grouping symbol. So we're going to perform 10 minus 3 first before applying your factorials. So therefore, we will have 10 factorial over 10 minus 3 is 7 factorial. Then we expand 10 factorial up to 7 factorial. So we will have 10 times 9 times 8, 7 factorial over 7 factorial. Then we cancel. So therefore, we will have 10 times 9 times 8, which will give us 720. Okay, so let's have another example. So again, PEMDAS rule, we apply first the operation inside the parentheses, and that will give us 9 factorial over 6 factorial, 3 factorial. So since we have here 2 factorials on our denominator, we're just going to choose one to cancel, which is the 6 factorial. So therefore, we will have 9 times 8 times 7 times 6 factorial, expanding 9 factorial up to 6 factorial. Then we will have on our denominator 6 factorial times 3 times 2 times 1, expanding 3 factorial. So we don't have to expand the 6 factorial because we're going to cancel it with our 6 factorial on the numerator. Then on our remaining numbers, 9, 8, 7, 3, 2, 1, we can still cancel 9 and 3, which will give us 3. Then 8 and 2, which will give us 4. So the remaining numbers are 3 times 4 times 7, which will give us 84. Okay, so that's it. Thank you for watching and hope you have learned something from this video.